I did not exactly finish this section, and I want to describe, or I want to finish this off with you. So let's do that now before we move on to the next part here. So the part that I'm looking at is describing all points within a distance d of x minus a. So before we talk about this, we really need to review, or we need to discuss absolute value. So when you guys see this absolute value symbol, how do you think about that? Does anyone have any response? We had already discussed that it was a piecewise defined function was one way that we could do it. But does anyone have a way that they think about it in terms of distance?
I just like to think about it as how many spaces are you moving
How many spaces you're moving away from zero, maybe?
from whatever origin you're starting at.
Oh, okay. So I think that's a great way to think about it. Um, one way that I've heard students think about it is they've thought about it as distance from zero. So, you know, if someone says, for example, absolute value of x is equal to 1, you could draw a little number line to represent that idea. So if you have this little number line here like this, it's like here's 0, and then you know the number 1 is a distance 1 from 0, so that's on one side. But then the number -1 is also distance 1 from 0, and that's on the other side. So when we say the absolute value of x is equal to 1, they're really describing 2 points, all the points at distance 1 from 0. Does that make sense to you guys as a starting point? All right. So then, what if I did something like, what's the absolute value of x minus 2? Well, that's kind of like distance from 2. So if I said absolute value of x minus 2 is equal to 1, how does the situation change? Well, it's going to be kind of similar. We're going to draw a little number line again. But this time, you know, maybe I'll put the 2 over here. The center of the thing is at 2. And then if you go at distance 1 on either side, you're going to have a 3 on this side and a 1 on this side. So when I look at this situation, we have that. So one way that you could think about this, and we're going to think about this later on today, is when you see this x minus 2 inside the absolute value. Today we're going to learn about graphing with transformations. And this x minus 2 is kind of within the absolute value, kind of corresponds to a horizontal shift. So it's almost like we took the first graph and we shifted it horizontally by 2 spots. And I think you guys can kind of see that. I didn't line it up right, so I wasn't really planning to line it up, but if I line it up. So can you guys see we've just kind of shifted that? Is there any questions about that? So these are points that are distance 1 away from 2 or distance 1 away from 0. Oops. So what happens if I wanted this within? You see this word here, within a distance d. Well, I'm not saying that exact distance is 1. I'm saying it's within a distance of 1. So then what would happen would be this would change to an inequality. So we'd come over here, we'd, instead of having equal to 1, we might put less than or equal to 1. And what that means is you want everything that's within -1 to 1. So if I go to shade this, if I went to shade this, this would look something like this. It's all these points in here. Does that make sense to everybody? Is there any questions about that? Okay, then, Of course, there's nothing special about the number 1. You could do it within a distance 2. You could do it within a distance, really any number, any positive number that you like, and it would still work out. So, if I were to just say less than or equal to over here, then I would be talking about this set. Okay, so this is like a graphical description. So what we do sometimes is we could solve these things algebraically as well. So let me discuss that with you. So let's say that I wanted to describe the set x minus 3 is less than 2, right? And I want to do it algebraically. I don't want to do it necessarily with a graph. So what we could do is we could transform this inequality into a compound inequality in the following way. If I have absolute value of x minus 3 is less than 2, that's basically saying the same thing as x minus 3 is between 2 and negative 2. And I hope that's clear after looking at our earlier example. It's almost like x minus 3 is the middle, and then we're going 2 on one side and 2 on the other side. And if we want to isolate the x value, all we got to do is add 3 across. So add 3 across inequality. Okay. And then when we do that, what are we going to get? We're going to get 1 is less than or equal to x is less than, oh, not less than equal, sorry, just less than, which is less than 4. Okay. So 2 plus 3 is 5. So we have that. Okay. And then if you wanted to graph it, you could do that. The graph would just look something like this. Okay. So we have here's 1, here's 5, 3 would be right in the middle, and then we're going to have open circles and open circles because that's a inequality, and then we just shade all the numbers in between here. Does that make sense to you guys? Any questions? So let's look at example 9. When I revise this, I need to put more room there because I talked about it more than I thought I would. It says, describe the set of all points within a distance 0.1 about x equal to 3 using both absolute value and interval notation. Okay. So how are we going to do this? Well, in general, it would look like this. If I want to describe the set of all points within a distance d of x equal to a, distance, so I'll write this, within a distance d of point A, this is how it would look. You're going to take absolute value of x minus a. This centers the interval at a, and that's going to be less than d, whatever that is. Okay, so that's how you do it in general. In this particular case, we're just going to substitute the values in that we have. So we're going to have absolute value of x minus 3 is less than 0.1. And then we can now set up the compound inequality. So that's the same thing as saying x minus 3 is between positive 0.1 and negative 0.1, right? And then finally, what we want to do is we want to add 3 across. So then we get a nice inequality. So if I add 3 all the way across, we're going to get the following. We're going to get 2.9 x and 3.1. So So if I wrote that in interval notation, that would be round bracket 2.9 comma 3.1. Those would be my two answers. Wait, did it say to graph it? Let me see here. Describe using both absolute value and interval notation. Okay, so really this part right here is the absolute value notation, and this right here is the interval notation. So let me put a box around here. Okay, any questions? All right. Cigar, I saw that you are here. Did you understand what I was saying about the homework?
Yeah.
Okay, because I just showed the class at the beginning, but we're good, I think.
Yeah.
All right, perfect. So I wanted to show you guys one other thing here. Give me 1 second. Let me see if I have the textbook open. I do, and let me go to so let me share something with you real quick. Hold on 1 sec. So on your screen right here is this thing called the precise definition of a limit. And ideally, I need to teach you this. I'm worried we're going to run out of time, so I usually move this topic to the end of the course. But I want to highlight one part here. Do you see this part on the bottom right here? That part on the bottom is basically describing a distance. So this is going to be a little interval. The center of the interval is at A, and then we're going to go a distance. That curly D is called delta. We're going to go a distance delta on either side. Okay, so that's really this part of it. And the zero part in front just means you don't care what the function value is at A. So at A, X can be anything. So anyways, I just wanted to tell you why we care about this. This might be coming to our future. Okay. So if you haven't tried that homework yet, please finish it up and submit it, and I'll give you feedback on it. And we have that. Any questions? Okay.